morning, good afternoon, and welcome to today's webinar. We want to thank you for joining us. We're holding a webinar today about building geofencing apps, and we're going to be hearing from Andy Bui, our senior consultant here at Mogic Software Enterprises Americas. My name is Glenn Johnson. I'm a senior VP here at Mogic Software Enterprises Americas, and we're happy to have you with us on today's webinar. What we would like to do is provide you with an opportunity to ask questions. To do that, enter them into the question box, and we'll be happy to share with you at the conclusion of the formal presentation with any answers that we can find for you to those questions that you might have, and I'm sure there'll be a few, so this is great. We're looking at almost an entirely technical hands-on presentation today. Andy will have a few prefacing words just before we begin. Although I believe most of you know Mogic Software, we will remind you that Mogic Software is a publicly traded company on the NASDAQ exchange under the ticker symbol MGIC, founded in 1983, and we have had over $176 million in revenue in 2015, some 1,300 employees, 24 global offices, customers in over 50 countries, and some 3,500 business partners with millions of users worldwide. So as a company, we're well established, and I think we are ready to begin today's presentation. So what I'm going to do at this point is hand things over to Andy Bui as the organizer. And Andy, from here, you can take it away and begin today's webinar session.
All right, perfect. Thank you, Glenn. Okay, so for today's webinar session, as Glenn had mentioned, we are going to be going over geofencing. So what is a geofence? A geofence is a virtual perimeter that is created on a geographical map, if you will. And basically, these geofences or these boundaries are utilized to handle specific area or geographic events. Some of these use cases include work order validation. For instance, suppose we have a work order management application or interface, and we want to validate that the work orders are being processed or closed out authentically. One possible way to do this is to ensure that when the work order is closed out or when the technician has verified that the work has been completed, part of the approval process that the work order submission or the work order labor submission would occur within a geofence of the building of where the work order was placed, right? So the use of a geofence is called geofencing. And when it comes to geofencing, there are endless capabilities that you can use geofencing to further extend your applications and your application's control. Another example of geofencing is firearm locks, for kind of a higher level example here. For instance, if firearms are being stored within a vault or with a secure area, a lock could be placed on them. And in the event that the lock is outside of that building or a geofence perimeter created around that building, then the lock will be enabled, and as a result, the firearm will be disabled until it is within the geofence. Of course, other questions come into play. Why should the lock be unlocked inside the building? Why would you want a bunch of firearms being unlocked inside the building? So again, this is just something to further extend the capabilities of your applications and create a more intuitive user experience. Okay. So when it comes to adding geofencing capabilities into your applications, there are a couple specifications that need to be taken into account. One of these specifications is what the geofence's shape will look like. From a developer standpoint, this will play into what algorithm or how you handle the geofences in your application's logic. For instance, we have diagrams 1 and 3 here, and diagrams 1 and 3 are a circular geofence. This is one of the easier types of geofences to utilize when programming your applications, because in a sense what you're going to do is be taking the device's location and creating a crow distance from the center of the geofence or the circular geofence. And if that distance is greater than the radius allotted for that geofence there, then as a result, the device is considered outside of the geofence. Okay. Another shape that can be taken into account for geofencing are rectangular shapes. With rectangular shapes, it'll basically be a combination of the min and max points of the vertices of that rectangular geofence to determine whether or not the device is in the geofence, right? If the device is outside of the geofence, then one of the latitudes or longitudes or XY coordinates will be greater than the range of the min and max of the rectangular geofence. So those are the two basic concepts of geofences and the basic shapes. And as you can see, the logic to actually determine whether or not the device is in the geofence is pretty straightforward. But then we move on to diagram 5, which is a polygonal geofence. This is where the amount of vertices or the shape isn't exactly completed necessarily, or there may be holes within the geofence, right? Maybe a specific wing of a building wants to be included with the geofence, but a specific building in that geofence to not be included, and as a result, it creates a hole. Now, as you can see, we kind of went over the circular geofence and the rectangular geofence and its logic, and if we try to apply those algorithms to this polygonal shape, it's not going to necessarily work. Right. For instance, in this diagram 5 or this geofence figure 5, in the event that the point is within the building where my mouse clicker is here, if we use the rectangular shapes algorithm for this shape, it would deem that the device is inside of that gap or that white building there. However, obviously it is not in that geofence. And in today's session, we're going to go over how to handle scenario 5. Okay, and the way that we're going to do that is there's two main algorithms when it comes to determining whether or not a point, or in this case a device, is within a polygonal geofence. Okay, there's the crossing algorithm and the winding algorithm. And the algorithm we're going to be working with today is the crossing algorithm. And basically, at a high level view, what this algorithm does is it draws a horizontal line through the point in question, and it counts to see how many intersections are, how many times this horizontal line intersects with the polygon. Okay, if it intersects an odd amount of times, in this case, we're looking at the in dot here, it intersects one time, and an odd amount of times, it's determined that the point is within the geofence. If it is an even amount of times, then it's considered out of the geofence. You can think of this as an entrance and an exit, right? For every entrance, if there is an exit, then we are considered outside of the geofence. Okay. So what we're going to do in this application is we're going to apply this crossing algorithm .NET code to our Mogic XPA application. And what this algorithm does is essentially it checks the latitude points of our vertices A and vertices B against our device's latitude point. Okay, and as you can see, it takes in an array, and with this, we're going. The array is of all the geofence points and all the vertices. So it is undetermined how many actual vertices are in the shape prior to going into checking whether or not the application or the device is inside of the geofence. But what it's going to do, it's going to loop through every vertices, draw our diagram, and as a result, and afterwards, it's going to keep track of how many intersections there are. And at the end, after we reach the last point, it checks to see if the amount of intersections is even or odd, and at that point, we'll know if the device is within the geofence. Okay, so what I'm going to go ahead and do is take you through an application demonstration here of an app we already developed. There's some extra little pieces in here where we'll go ahead and show a visual representation of what our geofences look like. Okay, so I'm going to go ahead and switch gears here and show my Nexus 7 tablet device. Give me 1 second. Okay, and then let me go ahead and start my server as well. Okay, so this is an application that we generated. And what it does here is it allows us to manually enter in our latitude and longitude coordinates. And also I have some preloaded geofences in the application. Okay, so for instance, I have my geofence 1, which I'll go ahead and add, and I'll click load. And what it's going to do is it's going to show me a Google Maps generated HTML page with multiple points. And this here is our Laguna Hills office here in Irvine, California. Okay, and if I go ahead and enter in our second geofence, okay, this is going to load a geofence around the Hyatt Mission Bay Hotel where we had our conference this year. Okay, so basically what I'm going to do now is I'm going to select this Get My GPS, and what this does is this Get My GPS executes an XPA internal function that retrieves the device's GPS coordinates. After a little bit of time querying, it's going to go ahead and add the GPS coordinates to my latitude and longitude, and it's also going to refresh my map of where that GPS coordinate is located. So as you can see, I am currently inside of our Laguna Hills office. So I'm going to go ahead and check back, enter in that I want to verify this device's coordinates against Geofence 1. And when I click this check here, it's going to go ahead and process each of these 4 vertices through our algorithm, and it's going to let me know if I'm in the geofence or not. So here the device's location is currently within Geofence 1, which is of course correct. We are here inside of the building. If I change it to verify against Geofence 2, right, over in San Diego, if I click check, it's going to give me my you are out of the geofence. Okay, so pretty straightforward concept with the application, right, just checking to see with whether or not I'm in the geofence. Okay, so again, what business value does this bring to your application? I brought up the use case for work order management. There's also cases as well as a district or regional territories, right? Suppose we have a CRM and we want to check, a salesperson wants to go into their application and check to see what customers or what accounts are located nearby. A geofence can be set up around a specific territorial cover area as well, to let that salesperson know these are the accounts that are within your region or within your fence. Okay, so let me go ahead and switch gears now. I'm going to take you behind the scenes, and I'll go ahead and show you the Mogic XPA code. All right, so what we did here was, this is the Mogic XPA Studio, and what we did was we went ahead and created 2 tables, and the 2 tables are our geofences and our vertices table. And what we did with this table here is we created a geofence. I have 3 geofences. Okay, so I'll go ahead and show you the view. And this is just the header of the geofences. We have geofences with their name, the geofence ID, and a brief description of them. But the meat of the geofence is within the vertices table. And the vertices table, the geofence's key is the geofence ID. And here we're linking the vertices with the geofence ID and adding in each vertices latitude and longitude here. Now what I went ahead and did is all I simply did was pulled up Google Maps, clicked on a specific point, and from there I was able to receive the latitude and longitude of that specific coordinate, and I entered it here inside the table as a GPS coordinate. Also with the vertex ID, the order is important. The order of the vertexes here go from point to point. So the first vertex ID 1 here, for instance, is 1 point in the corner, and then the vertex 2 is the next point that would be drawn inside of the shape. Okay, and the reason why the order matters here is because when we plug this into our algorithm, what we're doing here is drawing an image, and as we go from, we're taking in 2 vertexes in the algorithm, and from there it checks to see if there is any vertical or horizontal intersection for that line, counts it, and then moves on to the next 2 vertices. So let's go ahead and take a look at the algorithm, and we'll go ahead and zoom here. Okay, so for those of you that are not familiar with XPA, this is our Mogic XPA Studio, and what I'm designating here under this program, programs are what we like to refer. We like to refer to these as programs, or kind of methods, or basically some kind of functionality that we're going to program here, right? And inside this method, we have our data view, which lets us go ahead and designate what data sources we're going to be accessing. So I'm accessing my vertices table, I'm sourcing my vertices table and passing it 4 parameters. I have the latitude, the longitude, my geofence, and my whether or not I'm in the geofence. Okay, so the latitude and longitude, the first 2 parameters here are my device's location. The third parameter, which is the geofence parameter, is the parameter of which geofence I'll be validating my device's location to. And then lastly is the output or the return, which is the Boolean of whether or not the latitude and longitude parameters are within the geofence parameter. Okay. I'm also performing a link query to go ahead and pull in the quote-unquote next vertices in my vertices table. Okay, so this gives me my going into this main source here gives me my vertices n, and the link query here gives me my vertices n plus 1. Okay, and now the actual logic or the algorithm being played into Magic XPA here is being, this is the Magic XPA translation of that .NET code that I had showed you earlier in the presentation. We've taken an array of points and we've mimicked an array by creating this the vertices, main sourcing the vertices, and link querying the n plus 1 vertice. And from here, all we do is we plug in those two vertices, we store the first coordinate, because when we reach the last coordinate or the last vertices inside of our geofence, we need to link it back and draw that last line from the last vertices to the first one, right, to complete the shape, right? So again, here after we go ahead and store the first vertices coordinates, we go ahead and check to see if there is a next point. If there is, meaning that it is not a last point, it's going to go ahead and plug in that logic with some formula, check to see if there's a horizontal, if there is a horizontal intersection. If there is not a horizontal intersection, then it will check to see if there's a vertical intersection. If there's not a vertical intersection, then it moves on to the next point. However, if there is ever an intersection at any given point there, it goes ahead and stores. And what we're actually doing here is instead of storing the amount of intersections, it's just flipping the is in geofence Boolean, right? It's negating it. So as a result, right, 2 negations equals a positive, and 1 negation equals a negative. So again, that's how we're mimicking the odd amount of intersections, which is inside of the geofence, or the even amount of intersections, which is outside of the geofence. All right. And that's basically the gist of the demonstration that I wanted to show here. Glenn, do we want to go ahead and open up the questions, maybe show a little bit more, see where the questions are veering to?
Sure, we can open that to the questions, absolutely. So let's go ahead and do that. If you have questions, please enter them into the question box or to the chat box, and we'll go ahead and address those as we see where there might be areas where you want to see more about how to build a geofencing app in Magic XPA. I know we've got a bunch of you out there, so please don't be afraid. Okay, here's Todd. Will this sample app be available for download?
Yep, I can put the source code up to wherever Glenn would like it. But yes, we do have this packaged. Glenn, I guess that's a question for you.
Yeah, we can put it on the shared on a Google Drive, and I'll send it to the participants in today's webinar. Does that work for everybody? Yeah, Carl says yep. Okay, thank you, Carl. Oh, the Carlos, I guess it is. Got cut off there. Sorry. Any other questions? Oh, here's another one. Is there any reason this would not work in an Android offline task? Oh, that's an interesting question.
An Android offline task. Okay, so the application is not offline. I do not see a reason why, other than accessing the geofence's vertices. As long as you're storing that in an offline table, then yes, you could perform this functionality offline. Right, the actual logic itself in terms of determining whether or not on a data level can be handled offline. The only issue I could see here is if the device was not able to retrieve its GPS coordinates. Okay, so if the device was in airplane mode, then as a result, the device would not be able to use its GPS chip to determine its location. Right, so that's the only time it needs online functionality. And again, retrieving the device's location is a client-side task. So it does not need connection to the XPA server to perform that. So yes, this should work offline.
I have a question, Andy. I know, how secure is this? Because sometimes it seems like people can trick GPS locations. How much can you rely on this as being, absolute information?
Right. So for authenticity of the GPS location, that comes down to the device, right? Natively, when the Magic XPA client is retrieving the GPS coordinates, it's retrieving it through the native APIs of the operating system, or the native services of the operating system. So if, for instance, if a device has GPS spoofing on it, then again, the GPS coordinates are being retrieved the same way any other application would retrieve the location from the device. Okay, so in terms of security, if you need more security in that aspect, then that will have to be external native code that would be added to the application. But by
Right.
default,
So,
yes, XPA, yeah.
yeah, so it's just important to keep that in mind, although this is helpful to include geofencing. You can't assume that it's foolproof from a security standpoint.
Right.
Right, okay. Depending upon the device. All right, that makes sense. If you replace the .NET, then can the same be done with Unipass if we went back to Unipass?
Yes, in terms of logic, Unipass would work as well. The issue with Unipass, though, is this here is a mobile application or a RIA application, right? So Unipass does not support mobile applications, but the actual logic or the logic or this program here that checks to see whether or not it's within the GPS coordinate, this would function on Unipass as well.
Right.
I mean, the code itself is quite simple in terms of architecture.
Okay, good. Thanks for that question, Isaac. Any other questions out there? Give you just another moment to think of a question. Well, I don't see any other questions coming in, Andy, so I want to thank everybody. Thank you, Andy. Thanks to all of you for joining us, and we look forward to seeing you again soon on another Magic webinar. I hope this educational webinar has been useful to all of you. Have a great day.
Yes, thanks, Glenn.